Hello everyone, I'm Amir. Welcome to another training video. In the previous video we talked about how to run ungrib program to extract meteorological data from FNL data. In this video we want to repeat the same task, but instead of FNL data we want to use ERA5 data. So the first step would be downloading ERA5 data. How you can download ERA5 data? Just search for ERA5 hourly data. You will see two kinds of data. The first one is ERA5 hourly data on single levels. Open it. And the second one is ERA5 hourly data on pressure levels. Open both of them. So you see that unlike FNL data, that's all kinds of data on atmospheric pressure levels and data on surface levels are in the same file. For the ERA5 data, you have to get the data on surface and pressure levels in two different files. So let's start with the ERA5 data on single level or on the surface. For downloading it, you need to get at least a minimum number of atmospheric variables. How you can know about those minimum number of atmospheric variables? Just go to my GitHub page. In the atmospheric science repository, I will provide the link of this repository in the video description. You can find two codes here, ERA5 level and ERA5 surface, and if you clone this code you can find the exact names of the minimum variables you need to download from ERA5 data. This is actually for the atmospheric pressure levels, and the other one is variables on the surface, these variables. So you can get these variables one by one. If you don't want to use the code, you can get them manually just by checking the required variables here in this user interface. You can check the required variables and you can check the date and time for your simulations and also the extension of your domain, and after that you should get the data by grib format. You should pay attention that the netcdf is not used for the WRF model. For running the WRF model, you should get it by grib format. So the same process is for ERA5 data on pressure levels. There is a minimum variables. You can find the minimum variables here in the other code, like geopotential, relative humidity, specific humidity, temperature, U component and V components of wind. The number of variables is lower than the surface variable. You can check them here and download them manually. However, we use the codes here, and before running the code, as I told you, you need to modify the code for the exact time and the exact date and time, and also the exact area extent of your simulation domain. So let me open our name list, and the date and time of our name list is 2022, the third month, and the days 13 and 14, also 15. And this is okay. Actually, I have already run this code, so I just want to show you how to get to the process, get to the final process. Okay. So after running this code, this is a Python code. After you run this code, let me make a new directory, temp, level grib and single grib. If I run ERA5 single, I just want to show you how to run it. Just run it. And one other important point that I should tell you is that For running this code, you need to install a specific you need to install a special Python module which is required to running this code. And you can see that data has been retrieved by this name, single.grib. I just wanted to repeat this task to show you how you can run this code. But before running this code, as I told you, you have to ERA5 Python API. You have to install a special module. The name of this module is cds, and here you can see a manual or a document of how you can install this CDS module on your system. So it's necessary for running that code to have this module installed on your system. I will also provide you this link on the description so you can read it and install it. So let's go back to our WPS directory. Okay, so I have downloaded level data and single data, and these names have been actually set in this code. In the bottom of this code, the name of the file, you can change the name of the file. And I have two data files, one of them for atmospheric variables on pressure levels, and the other atmospheric variables on the surface or single layer, which represents the surface. I go to the WPS directory. I remove grib files from the previous run, and I also remove these files because I want to run it again and show you how you can run ungrib with ERA5 data. Okay, now you need to link to these downloaded ERA5 data, but for this case, because your data are separate in two files, you need to run ungrib run ungrib two times. Actually, one time, the first time is for single data or surface data, and the second time for pressure levels. So for the first time you link to the, let's say, surface data. Let me get the absolute path to this surface data. Okay, link. Okay, and you can see that if I show the path of this grib file, it is actually linked to the single or surface data. Now open name list, and here change this file to a better name like SFC, which represents surface layer or surface data. Run ungrib. One point that I forgot to tell you is that our vtable has been set for vtable GFS. Okay, this is actually not an appropriate option for ERA5 data. For ERA5 data, you need to change vtable to the special vtable for ERA5 data or ECMW. ERA5 data is another type of data of ECMWF. So I link ungrib variable vtable ERA interim pressure level as V table. File exists. Let me add F option, and now V table has been linked to a special V table of ERA5 data. And now I can run ungrib. Okay, it has been finished for surface data. Now you have to link data to the pressure level data. Let me get the absolute path to the level data, and I link to this data. You see that it is linked, grib, our grib file is linked to the level data. Now before running ungrib, open name list and change your surface to PL, which represents the pressure level data. Save it and run ungrib again. And you see that now you have two sets of data. One of them is for pressure level and the other for surface data. Now you are ready to run your the next step, which is metgrid. For running the metgrid, you open name list. If I want to provide you a simple description of metgrid, metgrid is the final step for running WPS, final step of WPS or WRF preprocessing. Metgrid actually puts the data extracted from global data extracted from either FNL or ERA5 data on your simulation domain. So by ungribbing, you just extracted variables, atmospheric variables. But by running the metgrid, you actually put those extracted data on the grid points that have been made by GeoGrid, the first section, the first step of the WPS. So before running metgrid, you should set the suffix equal to the suffixes of ungrib. For ungrib, we had two suffixes, prefixes, not suffix, prefixes, PL and SFC. So we specify the prefixes of PL and SFC here. PL, two sets of PL and SFC data, and I run metgrid. You see that metgrid is run for both domains, domain 2 of 2 and domain 1 of 2. And it's finished, and you have the output of metgrid data, and now you are ready to run your model. You are ready for the final step or final stage, which is running the WRF model. Before that, let me open one of these files. Inside of this file, the atmospheric variables are mapped on your domain, on the grid points of your domain. For example, this one is albedo. You can this is actually NCView software. It's a very simple and straightforward way of showing density of data. And this is albedo. You can see other variables like temperature and wind speed. This is for the first domain, and also you can show the same data for the second domain. And you see this is part of the Persian Gulf, and the same situation is for the second domain. Now we will go to the next step, which is the final run of the WRF model.